This video will be taking a look at some key skills, but also some of the kind of core concepts about one of the major things in algebra and one of the major uses in algebra. So we're going to introduce equations, we're going to introduce inverse operations and equivalent equations, including solutions to equations. So first, you start with a simple idea of what is an equation. An equation is simply a mathematical sentence that tells us the two quantities are the same. Equation equal, it tells us two quantities are the same. So although not a really powerful thing, 8 plus 8 equals 10 plus 6 is a true mathematical sentence. There's no unknowns to it. There's no mystery to it. We can clearly see the quantity on the left is 8 plus 8, which is 16. And the quantity on the right is 10 plus 6, and that's 16. So this is an example of an equation with no variables. This is a equivalent equation to the last one. All that's happened is the right-hand side has been renamed as 16, but it's still a true equation. What we're usually interested in is how are we going to use equations as a tool to help us find unknowns, since unknown quantities are really at the core of algebra. So here's an example, and you might recognize it from a previous video if you watched it, where we knew at some point that Taylor, if you added 2 years to her age, you would have found 16, and 16 happened to be Declan's, her brother's age at that point. But this is an equation which is ultimately true because the quantity T, Taylor, that's not 16. She wasn't a 16-year-old person. She was 14, it turned out. But her age plus 2 is equal to 16. So this is a mathematical sentence that tells us two quantities are the same. T plus 2 is equal to 16. And when you're given an equation with a variable in it, even if you didn't know to begin with that Taylor was 14, there's ways to unravel the puzzle and to figure out what the unknown piece was. And that the main technique for doing that is going to be to use inverse operations. It's not the only one, but it's really the go-to one. So what's an inverse operation? In the equation we see, there's t, and then there's an operation plus 2. And it's the plus 2 that brought t up to 16 in value. So the operation that we see is plus 2. Well, an inverse operation kind of takes you back in time. It takes you back to Taylor before we added 2 to her age. So inverse operations are two operations that cancel each other out. They undo each other. They kind of work their way back to the where you started, your original unknown. Equivalent equations are equations that you can write that replace one like t plus 2 equals 16, which is kind of this puzzle, and sometimes they're pretty complex puzzles with a equivalent thought, something you can conclude that's a little bit easier to decipher. So performing the same operation to two quantities that are equal result in two new equal quantities. So t plus 2 we know is equal to 16. And if we do something to t plus 2, and we also do that to 16, they won't be each 16 anymore, but they'll still be equal to each other because performing the same operation to two quantities that are equal result in two new equal quantities. So a lot of times you'll see people do this just for organization, say my quantity is on one side of the equation, my other quantity is on the other side of the equation. We know they're equal to each other. And if I'm going to perform an operation, drawing that line is sometimes helpful. What kind of operation? How do I choose an operation? Well, you choose an inverse operation to something that you see has been done to your variable. So when I see that add 2 has been done to my variable, then my inverse is subtract 2. And I do that to both sides of the equation. A balanced inverse operation will get you a true equivalent equation. And what's going to happen is because you're choosing inverse operations, you'll always be really clear about what's going to happen on one side. There's going to be some cancellation that happens. There's going to be undoing that goes on. And on the right-hand side of this equation, you're going to have a new quantity, which is equal to t, which is whatever 16 minus 2 is. So learning to write equations and show your work is really a helpful organizational tool. So that's a very basic equation to solve. It's a one-step equation, but it introduces the idea of inverse operations. And what you just arrived at was a solution to an equation. When have you solved an equation? It's when you've isolated one of the variables and you have a really clear statement that t, in this case variable, is equal to something. And sometimes it's a number and sometimes it's another expression. But an equation is solved when we revealed the value of the variable by undoing all the operations that had been done to it. So the idea of working order of operations, recognizing it, and then kind of working it backwards is going to become important eventually. The last objective for this video is going to be to introduce properties that ensure our work to solve an equation always results in equivalent equations. Everything in math is supposed to make sense to you. Everything is supposed to have a reason behind it. If something is done, you can say, I know that what I just wrote down was true because of some very pure, simple property. So here's a few equations we're going to look at together. And we're going to take a look at all the properties, or not all the properties, but a decent number of the properties that we're going to use. A lot of the properties have to do with balanced inverse operations. As we saw already, that if you subtract something from two equal quantities, you'll get two new equal quantities. That is not the addition property of equality, but that is the subtraction property of equality. Meaning if you subtract something from both sides of a true equation, you get another true equation. Multiplication property exists because if you multiply both sides of a true equation, you'll get a new true equation. Same thing with division. So basically that says you can do an operation to both sides of an equation. How that looks on paper can get pretty complicated, but right now the idea is pretty simple. So how do we use that balanced inverse operations to solve 3y equals 11? Well, the first thing we have to know is when you see 3y, it means 3 copies of y. It means 3 times y, 3 times whatever y is. You would need to multiply y by 3 to come up with 11. Now, what that problem does is it takes a pretty common tool away from people. Guessing and checking is a pretty common tool that people use early in their algebra careers, or just kind of like running through some numbers. Let's see, 3 times 2, no, that's not 11. 3 times 3, no, that's not 11. 3 times 4, no, that's not 11. And actually, we just hopped over 11. So some students then give up if they don't have this idea of inverse operations. So what I always want you to think is, if I don't have a logical way to do something, I have to trust these properties. If I apply the inverse operation division, that is a good way to undo multiplication. It's allowed to happen because of the division property of equality. I could divide both sides of this true equation by 3, and I know exactly what's going to happen on the left side. My 3's cancel, and I'm left with a y. Now, what's on the right-hand side? Well, whatever 11 divided by 3 is. And you have a lot of options on that. You could say 11 thirds. You could leave it as a fraction. It's my personal preference. Or you could grab a calculator and find out that it's 3.66666. Or maybe you're someone who likes mixed numbers better than improper fractions or decimals, and you know that 3 goes into 11 a little bit more than 3 times, but some fraction of a 3 is left over. Not quite another 3. It's a 3 and a bit of a 3. It's a 3 2/3. But we'll work on all those things as we work through the course. Right now, let's talk about some other properties, other types of properties. Sometimes when students learn to solve equations really visually and they rely on the way things are written, they have questions like, well, I don't like it when a variable's on the right-hand side. I hear that all the time. Well, what I can introduce to you then is a property called the symmetric property of equality, which in very simple terms says, if the left side equals the right side, well, then the right side has to equal the left side. And what that does for you, if you don't like the variable being on the right-hand side of the equation, you can take that expression and write it on the left side and write the right side on the left side on the right side. And now you have an equation maybe you're more comfortable doing an inverse operation for. Once again, what inverse operation would get rid of addition of 0.7? I see that my R had been there and I added 0.07 to it, and I want to kind of undo that. Well, that sounds like a job for subtraction. Subtraction undoes addition, cancellation happens, right-hand side becomes, careful on that one, that is a negative 0.04. And you might not be real confident with those kind of numbers, decimals and negatives, but you should be really confident with the subtraction property of equality. If you can identify the operation that happened to R, then you can undo it. And then the final example here, oh, by the way, yes, down here, we do say that you don't need to use the symmetric property of equality. You don't need to rewrite the equation. Some people are going to be really confident saying, well, whether it's on the right-hand side, R plus 0.7, I could subtract 0.07 from both sides and would have gotten the same result. My last example, that is going to be a chance to, again, some people don't like it when they see a number as a first term and then the variable next. So those students might be interested in the commutative property of addition. What's that mean? It means that you can rewrite a side of an equation by rearranging the terms as long as you maintain the signs of each terms. So right now on this left-hand side, I have a negative 2 1/4, which is creating part of the quantity, and I have a p that is creating part of the quantity. And those two quantities combined, added together, get me 3/4. Well, if I rearrange those terms and I put my positive p first and my negative 2 1/4 second, now it reads very different, but it might help you identify what inverse operation to use. And that's still equal to 3/4. The inverse operation that we're going to have to use here, because we have to undo the minus 2 1/4, that sounds like a job for addition. So we would add 2 1/4 to both sides. And again, I know people are intimidated by fractions, but this is actually a really nice pairing. 3/4 needs one more fourth to become 4/4. 3/4 and 1/4 become a whole thing. And so that 2 and a bit becomes 3. So p equals 3. So in this video, then, you've got an introduction to a few problems, a few equations. We're going to be using equations a whole lot. Hopefully the idea of inverse operations is coming along. You'll get used to rewriting equivalent equations. I hope you got some examples of how to write equations and kind of record your work. And then also just some tools you can use if you don't like the way something's originally written.